Okay, I am going to be recording my lesson from yesterday because there were big problems yesterday. So I'm going to be recording the answers. I'm going to go through questions 1 through 4 for assignment 6, which was the applications of linear functions. As I was mentioning, this is a summary assignment. So if you can understand this assignment, you basically got the whole unit understood. This is the applications of linear functions. A linear function is a function that is represented by a straight line graph. Now the line can be either trending upwards or downwards, depending on the situation. But once we have the graph of a line, the graph of a line tells us the situation and describes the story, what's happening in the relationship we're studying. But once we actually have the graph of the line in our calculator, and we can see it in the window, we can answer any other question that the situation asks of us, right? We use the graph of a line to make predictions for the future. And making predictions helps us make sense of our world. So let's take a look at number 1. And we can see that they've got, the story is the cost of sending a school volleyball team to a tournament. And they give us the equation of the situation. So that's a great thing. If they give you the equation, half of your job is done, right? There are 2 types of questions in this unit, basically, or 2 types of questions that you can see in any type of linear function problem. They're either going to give you the equation or you have to come up with the equation because they'll give you a table of values. This one's a little more difficult because it requires more steps, and so obviously there's more to know. If they give you the equation, your job is basically almost half done. All you have to do is enter it into the y equals screen, the calculator, and adjust your windows. Really, it's about adjusting your windows. And if you know a little bit about the equation of a linear function, even the window settings become more and more easy to understand. Okay, so the first thing I'm going to do is I'm going to just see what they want me to do in number 1. So number 1, A, the cost of sending a school volleyball team to a tournament follows the equation y equals 21x plus 140. X is the number of players and y is the cost in dollars. Sketch a graph. Well, I sort of know what this graph will look like. So I'm going to start. I don't know exactly what I'm going to do for my scale yet, but I know that if it says sketch a graph, I know this is a quadrant 1 graph, right? And the reason I know it's a quadrant 1 graph is because this just is involving positive numbers, right? So many of your situations in the applied course are just going to involve quadrant numbers. So this is a quadrant 1 graph. Therefore, I can just sketch, I don't need all 4 quadrants. I can just sketch the first quadrant. And they're just using y's and x's, so I can use y's and x's. And it says x is number of players, y is cost. So this is number of players. And again, this is number of players on the volleyball team. And this is the cost in dollars. Okay. And this will be my 0, right? This is my origin. I don't need the other 3 quadrants. And what else do I know about the function? Well, if I look closely at the function, y equals 21x plus 140, I know that this is the y-intercept and it's positive. So that means this graph has a y-intercept of 140 and it moves up. That tells me a little bit about the windows already, right? X min, X max, Y min, Y max. Because this is a quadrant 1 graph, X min and Y min are going to be 0. I know my Y max. Well, the Y values start at 140 and get bigger. So my Y max has to be, Y is the cost in dollars. It's got to be way greater than 140, and I don't really know how much greater. So I'm going to put, I don't know, I'm going to put 500 in. And then let's see, and I can always change this later, right? I just want to get a starting point, and I usually leave my X max till I take a first look at the graph. Get your graphing calculator simulator ready and clear out all your old data. Go to the y equals screen. So I'm going to enter in, just move this up so you can see everything, 21x plus 140. And let's see what the graph looks like. Oh, sorry, I have to change my windows, right? 0, I'm just going to leave the x for now, 0. And I thought I'll start off with 500. Okay, let's see what that looks like. That's not bad, right? Okay, so I'm going to get two points on the line. Now, for a graph that's trending downwards, I can use my intercepts. For a graph that's trending upwards, I use my y-intercept, which I'm just going to double check, select value, put a 0 in for x. Sure enough, my y is 140. Now I need another point because you need 2 points to draw your graph. Remember what I told you previously? As soon as whenever you have something entered into your y equals menu, you're always going to have a table that shows up in your graphing calculator. So if I go second graph, I get the table, and I could just use any one of these coordinate points. So why don't I use, how about I use 5 and 245? Okay, so I'll use 0 and 140 and 5 and 245. Okay, so that means I think I'm going to go up by 50s then, if I can. So 100, 200, 300. I guess I didn't go up by 50s, I went up by hundreds. Okay, so 140, I'm just going to kind of guesstimate. Here's 140. That was my y-intercept, right? And now I have to do number of players too. And I was going to use the coordinate point 5, 245. Okay, so let's try this. One, 2, 3, 4, 5. So here's 5. So 245 is going to be kind of in the middle. Remember, you're sketching this graph. This isn't super precise. You don't have grid paper, but I am still using a ruler and a scale, okay? So this point is obviously 0, 140, and then this point is going to be, and I have to label my second point, when x is 5, y is 245. I guess I could label this one too. When x is 0, y is still 140. That means when there are 0 players going, this cost will still be 140. There's still a cost involved. And I guess that would be like for the bus. You have to pay the driver anyway, even if no students show up to go. So I just left my x max at 10, I guess for now. Okay, so sketch a graph, label scales, did that. That's part A. Part B, how much will it cost to send 20 players? Okay, so that's easy enough, right? That's second trace value. X equals 20. Okay, I see a problem there. Remember when I just left my x max? So I'm going to have to change my x max. Let's change it to 30 because I can't put a value in of x equals 20 when I've limited my x's to 10. Okay, so I got to readjust that. Go back to my window and I'm going to change this to 30. When you get to do more and more of these, you start to read a little further in the question to help with your windows. But I'm trying to sort of approach it like a student would approach. But in the future, I'm going to try and read through the question to help me set my windows. So your graph will look a little different. You don't have to change your sketch. It's still the same graph, right? Second trace value. This time I want to know what the cost is for 20 players. And it's $560, okay? So y equals 560. Now this is not enough of an answer because for someone who doesn't really know applied math, this won't mean anything. So you're going to have to write in words for a word problem. It costs $560 for 20 players. Okay. And then part C, how many players can the school afford to send if the budget is $980? Well, this time it's the reverse type of question. It's asking you to find X when Y equals $980. So for the flip type of question, we approach it in a different way, right? Remember, you enter into Y2 980. So you have 2 lines going, and then you go to your second trace, but you hit number 5, right? Intersect. And then you answer those questions, right? You say yes, enter, enter, enter. So it's a little more complicated when you're given Y information. All right, I go to my Y equals screen, and in Y2, I enter 980. Okay. And I can also see this, I got to go back to my windows again. I just noticed I want to put a Y80, but I had maxed out at 500. So I'm going to have to readjust my windows again. Okay, I have to do that. I had to adjust my Y max. Now I have, or my X max. Now I got to adjust my Y max. If I left my Y max at 500 and I put a value in for 980, I'm not going to see the 980, right? It's not big enough. So let's adjust that. Okay. So in my Y2, I put my 980. Now I press graph and I should see my 2 lines. Oops, and I don't. I'm going to have to readjust my X again. Okay, so let's go really big. I guess the lesson learned is you can go way bigger than you think you need to. So that's what I'm looking for, right? And I guess I'm just going to adjust my X too. I'll just keep showing you that I kept having to adjust. Okay, so that's where my answer is. So second trace, number 5. So I'm just entering. I'm answering yes, yes, yes. So for $980, I can send 40 students, right? X is 40, Y is 980. Okay. So X equals 40. So that's actually my answer, right? Just like up here. But I have to answer in words. Okay. So I have to say with $980, they can send 40 students or 40 players. All right, that was number 1. So hopefully that was semi-familiar to you if you've been working through these questions. Let's try number 2. I'm just going to do the first page, then later today I'll do the second. So number 2, again, they gave us the equation, right? So these are straightforward, I think, except for the windows. Carlos has $1,000 set aside to give to his 3 kids. He'll give each of them $15 a week until the money runs out. The equation that represents the situation, okay, great. They gave us the equation again. Sketch the graph. How much money will he have left? All right, so I'm going to do the same things I did before. Graph number 2. Now this is again a quadrant 1, right? I know it's a quadrant 1 graph because, actually I'm going to see if I can do something there. I know it's a quadrant 1 graph because we're talking about time and money, right? So once again, I just have to worry about quadrant 1 and you're just doing a sketch, right? And again, they're using X and Y, which is nice for us, X and Y. Let's see, the Y-intercept is $1,000, right? But this is a graph trending downward because of the negative leading coefficient. So I know it's going to start at 1,000 and drop down. Therefore, I really don't need much more after 1,000. I'm going to read through the question. How much will he have left after 2 weeks? Okay, so I don't really need that much for X either, right? Okay, so I'm going to just, I think I might just put down 500, 1,000. I forgot to label, right? X is time in weeks. And the Y value is money left in dollars. Okay, this is 0. I think I might just do like, actually I'm going to make a bigger scale. 1, 2, 3. All right, for this one, for the downward graph, okay, clear your calculator out, clear it out of its memory. So I'm going to enter the equation into y equals. So remember your negative sign is under the 3, negative 45x plus 1,000. Definitely have to change my windows. X min, X max, Y min, Y max. This is quadrant 1, so I'm going to have zeros for X min, Y min. X max, I'll leave it at 10, that's fine. My little sketch only goes up to 3, but 10 is not that bad. We started at 1,000, so I think maybe I'll do 1,100 for Y max. Oops. Okay. I only needed it to go up to 1,000 because, whoops, sorry about that, guys. Because this graph is dropping, right? So I entered in 0. I just left it as 10 for now, 0 and 1,100. This graph is descending, so I don't need to go higher than 1,000. And now I see, in order to see the x-intercept, which I do need that to graph, I'm going to need a bigger value for x max. I don't know, I'm going to go really big. I'm going to go 30. Okay, so I'm going to put a 30 there. And for a descending graph, the 2 points you can use to graph are your 2 intercepts, right? Any time possible that you've got 2 intercepts, use those to graph, because that gives you a really good indication of the graph. We couldn't do that in example 1 because our x-intercept didn't appear in our sketch of quadrant 1, right? So I'm going to use these 2 points. So second trace value, just to, sure enough, the y-intercept is 1,000. Okay, so that's right up here. It's my first point. When x is 0, y is 1,000. Okay, now I got to find my x-intercept. I hope I left enough room. In y2, I put a 0 in. And now I'm going to press second trace number 5. Okay, so this is what I want. Oops, I might have to make my x-intercept a lot bigger. Enter, enter, enter. 22.22. Okay, so wow, that's a really big x-intercept. So you know what? I'm going to say this is 10, 20, 30. Easy enough. So here's my x-intercept. So this point is 22.22, comma 0. And those are the 2 points I'm going to graph. Okay, so that's my graph. That's part A. Then they ask me, how much will he have left after 2 weeks? Okay, so how much will Carlos have left after 2 weeks? So that's an easy one, right? Second trace value. X is 2. All right, what does Y give us? 9, 10. He'll have $910 left after 2 weeks. And then how many weeks will it take for it to drop to nothing? Well, that's $0. That's our x-intercept, right? And it said round to the nearest week, so it doesn't want decimals. So after 22 weeks, he'll have $0. That'll be when the money runs out, right? When he has $0. Okay, so those were 2 similar situations in that they gave us the equation. So the only thing we had to do was play with the windows, and you saw what happened in my situation. I'm changing the windows all the time throughout the question as I need to, right? It's really difficult to get your window settings perfect on the first crack until you start, reading through the question. So don't worry about having to go back and change your windows. That's part of being a good problem solver, right? All right, let's take a look at example number 3, right? Because they do not give us the equation. So therefore, we have to enter the data in. See, this is a data table question. The end goal is still to get the equation, right? Determine the equation. Once we have the equation, we can solve any question they want. But first we have to get the equation. So here's my table. And this one's number of guests and cost of this, right? We don't have to do a sketch this time, but still this is my X, this is my Y. So clear your calculator of all its data. And then go to stat. Okay, remember how to do these, guys? The instructions are on page 13. So refer to page 13 of this booklet for further instruction, because I've already gone over these steps quite a few times. So I'm going to do this fairly rapidly, I guess. So just going to move this over a bit. In stat edit, I'm going to enter my data. So 50, 80, 100, 120, 200. Move over to the left or to the right. 2150, 3050, 3650, 4250, 6650. And now I definitely have to change the windows. The only nice thing about these X-min, X-max, Y-min, Y-max, the only thing that's nice about tables of values, it kind of tells you what you should set your windows at. I think I'm going to use zeros for X-min, X-max. This is quadrant 1, and I'll just start at 0. But let's look at X-max. So it goes up to 200. But if I look further in the question, it's asking for 550 guests, so I may as well be proactive. I'm going to put 600, up to 600 guests. And then here, let's see, the cost of my table, the highest cost is $66.50. But if I look further in the question, they're talking about 12,000, 25. So I'm going to put 15,000 here. Okay. And that way, that should be big enough. So 0, X min, X max 600, Y min 0, Y max 15,000. Now the only other change in when you're entering data in, you enter the data, and if you want to look at your data first, just turn your stat plot on. It's right above the Y equals, so turn that on. When you hit graph, you should see your data point. So sure enough, this is linear. Now, to get the graph, again, look to page 13. You're going to go stat again, but instead of edit, you've already edited, you've already put the data in. Now you want to calculate a line. So you're going to pick number 4, and then this should be familiar to you. Move down to the store reg, and you're going to press vars, yvars, function. You want to paste it into your Y1 screen, right? This is where the equation's going to go. And once you have your equation here, there, out pops your equation. So part A, my equation is Y equals, A is 30, 30 times X plus 650. Okay, that's my equation. Now, not only does it give you the info to answer part A, but if you look at your Y equals screen, when you did that store reg, it stored the equation in here for you. So now when I press my graph, there's my magic line, right? Once that line's going through the data points, then you can answer any further question. All right, part A we've done. Part B, how much will it cost for 550 guests to attend? All right. Now I could just answer any questions like I did before, right? In the number 1 and 2, I want X to be 550. Because it's saying I have 550 guests, that's an X value. So second trace value, 550, and I get Y equals 17,150. And again, I'm going to answer in words. It costs 17,150 for 550 guests. Okay. And then finally, part C. If the couple has a total of 12,500 budget for the whole wedding, And 25 of this is for other stuff. How many guests can they invite to dinner? So be careful. 12,500 is for the whole wedding, or sorry, yeah, for the whole wedding. But 2,500 has to be for probably the music and the hall. So this is 10,000, okay? This means they have $10,000 to spend on the dinner, which is the cost we're studying, right? This is the cost, these are the costs of dinners. So they don't have 12,500 for the dinner, they only have 10,000 for the dinner. All right, so this is giving us a Y value and we have to find an X. Those are harder. So enter into the Y2, you're gonna enter 10,000 in, and then you're gonna go to your second trace menu, and you're gonna pick number 5, intersect. And that's the enter, 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 right? Enter, enter, enter. All right, so here's my graph. In Y2, and remember my windows, I think I made my windows 15,000, right? So I shouldn't have to worry about that. Sure enough, I see my 2 lines. Once you've entered a Y2 statement in, you've got 2 lines in your graph, in your graphing window, right? A Y1, Y2, so you should see 2 lines. One is, slanted and one will be straight across. Second trace number 5, and it's sitting right there for me. So yes, that's my first curve. Yes, that's my second curve. Yes, I want you to take a guess. So that means when Y is 10,000, X equals 311.67, right? Which isn't a proper answer because this is the number of people. I can't quite afford 312. So they can invite, I have to round down for this one, 311 people. Because they don't quite have enough money for 312. All right, so that's the answer to part C, and I think that's it for that question. All right, so I'm going to move up, and I'm going to do one more question for this first part, and then I will video again later today, and hopefully YouTube is working properly today. Okay, now for number 4, if you can read this, a car is traveling according to this equation, sketch, and then they got me 2 answers here. So I'm going to see if I can fit everything. I don't think I can. So I'm going to do something kind of wonky, I think. There. Okay, so number 4, clear your calculator out. And then it says sketch the graph. So the first time they don't use X's and Y's, but we still have to enter into calculator as Y equals 90X plus 55, right? Because your calculator doesn't have D's and H's. But when I'm doing my sketch, I have to use D's and H's, right? Now let's see. This time, your y-axis is going to be called D and your x-axis H. This is a quadrant 1 graph again because we're talking about time and distance. So H is number of hours. And D is distance from Winnipeg in kilometers. Distance from Winnipeg. All right, so this is a graph, starts at 55. Trends upwards. So I'm not quite sure. These windows are a little harder to determine when it trends upwards. I know for sure my X-min and my Y-min are going to be 0. Let's see. Let's read further in the question. 3.5 hours. So I'm just going to leave this as 10 for now. I'm not going to change anything. But for Y max, let's see. I'm starting at 55 and getting bigger. I don't know. I'm going to go really big and just put a 200 in, like 200 kilometers. Okay, so enter into my Y equals screen. 90X x plus 55. I'm going to adjust my windows. 0, I'm going to leave that at 10 for now. I might have to go back and change it. All right, let's see what we get here. Well, that's not bad, right? I suppose. Okay, so let's just check this y-intercept. Second trace value, sure enough, it's 55. And I'm going to get another point on this graph. Remember, just go to the table. How about maybe 2 hours and 2:35? 2 and 2:35. Okay, I'm going to try and remember that. Just going to move this out of the way for a sec. So 2 and 2:35. So I'm going to go 100, 200, 300. This is just a real quick sketch, right? And I'm going to do 1, 2, 3, 4. Do this. Okay, so 2, 4, 6 hours. That's lots, right? So my first point is 0. When x is 0, y is 55, right? That's my y-intercept. And the second point I was going to use, remember how I found that? I have a y equals statement entered into your calculator. You can just go to the table, pick any other point you want. So I'm going to use 2:35. Okay, so 2:35. And I'm going to connect that. All right, so now we can answer the questions. Sketch the graph, give the coordinates of at least 2 points. I'm just referring to my questions here. I've done that. That was my part A. Part B, determine the distance from Winnipeg after 3.5 hours have passed. Well, that's an x value, right? So that second trace value, x equals 3.5. Second trace value. So 370. Okay, once again, that's not enough of an answer. The distance from Winnipeg is 370 kilometers after 3.5 hours. And part C, determine the distance from Winnipeg after 30 minutes have passed. So be very careful. They're trying to be tricky here. Your graph is not measured in minutes. It's measured in hours. So 30 minutes equals 0.5 hours. So it's the same type of question as part B. They're just seeing if you're paying attention, right? So it's second trace value. X equals 0.5. So let's see what y equals for this one. Second trace value, 0.5, half an hour. Y is 100. Okay. The distance is 100 kilometers after 0.5 hours. And then that's it. So there were 3 questions that gave us the y equals statement, which you can see sometimes the windows are a little harder in that. It's hard to get a starting point, but not so hard if you understand what the y-intercept is all about. Today I'm going to go over a couple more questions in this application question, or application assignment. So if you need to, please hop on, ask me questions in live chat or email me later. And then that's it for now, but I will see you later today.